What's up, math scholars? It's Mrs. Harp here. It's a Friday, so everyone's really excited for their fun weekend. We're doing 1-4 day 2, just more box method, but now we're going the extra mile in solving the things we factored. So who's excited? It's Friday! Marty was making strange noises, but it didn't sound like a noise of excitement. All right. Go ahead and jot down this quick vocabulary lesson here. You may hear me using these words interchangeably, so I want you to be familiar with the terminology. Roots, x-intercepts, solutions, and zeros are all the same exact thing. So when I tell you to solve something, you're basically finding the x-intercepts. Those things are called the solutions. Let me just show you visually what a parabola looks like. So here is my parabola. I'll make it pink. Here's the parabola. You all know where x-intercepts are located, right? Right here and right here. So these two pink dots, you didn't realize it till just now. These two dots are the location of the solutions. So this parabola would actually have two solutions because it has two x-intercepts. Okay? Do you think a parabola could ever have only one solution? They're thinking. What about this parabola? How many x-intercepts does it have? Only one. So this parabola would only have one solution. So yeah, it is possible. And then do you think a parabola could have zero solutions? Yeah, where would it be at? Where would it live? It would never touch. So it could either be like an opening up parabola up here that's not touching. It could be an opening down parabola down here that's not touching. But basically, yes, it is a possibility of having no solution based on where the parabola is. Okay? All okay with that concept? All right, moving along. Go ahead and jot this concept down, zero product property. I feel like you've heard of it before. If A and B are expressions, and A multiplied by B is 0, then either A was 0 or B was 0. It has to be true. All right, you do not need to write this down if you don't want to, just look at it. But basically, we're going to play pretend here. We're going to pretend that somebody had factored, and this is what they got when they had factored. Now, since this equation is set equal to 0, we're going to go that extra mile, and we're going to list out what the solutions are. So here's how you think about it. You have this binomial and this binomial that are multiplying to get 0. What has to be true is either this binomial must have been 0, or this binomial must have been 0. Now, for this binomial to be equal to 0, the value of x must have been a -8. Does it make sense? And for this one to be equal, that value of x must have been 9. So that's how you would list out this equation. Those are also the x-intercepts, so they're the p's and q's. This is kind of relating into what we did last week. Alright, so let's play pretend. Let's pretend somebody had factored and they had this. What would be those two x-intercepts? What would be those two solutions? Also called roots. Yeah? Perfect. -3 and 7. So those are the two solutions to this equation. Does that make sense? So it's up to you if you want to write that down. You don't have to, but you can. Some people are writing, so give them a second. All right, getting a little bit harder. What are the solutions to this one? Well, some people can probably find the solutions in their head, but some people probably are more visual with solving. So what I would suggest is take the contents of both binomials and set them equal to 0. And then just solve them both. So to solve this one, I would subtract 3 on both sides. And I'd divide by 2. So -3 over 2. And you can turn it into a decimal, but for today, I'm just going to leave them as fractions. Over on this branch, I would add the 5. And I would divide by 3, 5/3 to the other end. So both of those would be the solutions. They would be those x-intercepts if you graph the parabola. All right, so let's talk about how you too can be a math scholar. True math scholars can solve these ones mentally. They don't write off their work, and here's how they do it. They take the opposite of this number, and then they divide it by this number. So it would be negative 3 over 2. It would be positive 5 over 3. So do you see that technique? It's the opposite of this number over this one. But feel free to show your work and write it all out if you want to be really thorough. I'm going to be writing it all out just because I'm the teacher and I have to, it's kind of like my job, but you can definitely do it mentally. All right, so let's actually do one of these. Go ahead and jot this down. What are the root solutions of the equation x squared minus 5x minus 36 equals 0? So one really important fact before you want to start any of these problems is to make sure you're set equal to 0. If you're not set equal to 0, you're not going to be able to utilize that zero product property, so you'll need to get yourself equal to 0. So since we are equal to 0, we're ready. Is this going to be the box method from yesterday or that old method from last week? I call it the old-fashioned method. The old method from last week, the old-fashioned method. If you do use the box method, it would work, but you don't need to go through all that effort. What numbers multiplied to a negative 36 that would add up to a negative 5? Alex doesn't know if I can tell. No? Oh gosh. I thought you were looking at me. Kyle knows. Perfect. So, negative, did you say negative 9? So, negative 9, positive 4. Perfect. Negative 9 and positive 4 will add up to that negative 5. So this is now completely factored, but now we're going to solve it. So we're going to say to ourselves, what value of x would make this binomial 0? 9. And what binomial would, or what value of x would make this binomial 0? Negative 4. So it's almost like whatever numbers you select for your groups, for your factoring, the solutions are opposite of that. So it's C. Yep, good job. Alrighty, so we just have a little blurb that kind of says anytime you have a quadratic that can be factored and it's not prime, then you can solve it using factoring and the zero product property. So first things first, on this particular example, go ahead and jot it down. You want to make sure you're set equal to 0. We are. Thumbs up on that. You want to pull out a common monomial if you can. Is there a common monomial between the 3 and the 10 and the 8? No. So we are ready to attempt our box method for factoring. Let's stick our 3x squared in our upper left. Our negative 8 goes in our lower right. You want to multiply them together, and that's going to be a negative 24. So raise your hand if you know my combinations. I want to multiply to negative 24, add to 10. Nathan. Perfect. Positive 12. And negative 2. Be sure both those boxes get under x. Let's pull out from our top row our common factors. It's going to be a 3 and an x. And then we can work our way around the square. 3x times x is 3x squared. 3x times 4 is 12x. And then x times negative 2 is negative 2x. And it is good practice to check that last box. Negative 2 times 4 is negative 8. Alrighty, so here's what we're looking like in factored form. Yesterday at this point we were done. Today we have that one extra step. If this is what we look like in factored form, we must list out our two solutions. What would the solution be of my first binomial? Negative 4. And then the second binomial, maybe some of you can get that answer in your head, but I'm going to work it out by hand, because that's what math teachers do. I'm going to add that 2 to both sides. Get 3x equals 2. And I'm going to divide both sides by 3 and get 2/3. So the two solutions are negative 4 and 2/3. Now I forgot to tell you how you could check these. You could check these by either heading to Desmos or to your graphing calculator. Graphing this equation. Now you wouldn't want to type in equals 0. You would just want to type in this equation. But then you can look for where those x-intercepts are. So this would be a parabola that's crossing at -4 and at 2/3. Isn't that cool? It's a quick way to check. Another way you could check is just plug them in for x because they should yield 0. Okay. All right. This one's going to be a little bit harder. It looks longer, first of all. But what makes it a little harder is not everything is set equal to 0 right now. You can't use factoring, can't use the box method until everything's set equal to 0. So, I'll give you a second to jot down. My box a little later. Do you guys know how we can get set equal to 0? Do you know how we can get these terms over to the side and join their friends? How are we going to do that, Nate? Perfect. So that'll give us a -20p, he told me. And I'll actually move the 5 in that same step. How do we move the 5? Add the 5, and I put them right underneath their like term. So the 15 and the 5 will combine to 20. And then, before I head to my box, I'm going to check for that common monomial. Is there any common monomial that can pull out front? What is it, Mary? 5. And guess what? Once that 5 comes out front, it's not a box method after all. Because -20 divided by 5 is -4, 20 divided by 5 is 4. It's not a box method after all because there's no a value anymore. So these 3, to factor those, we can just use that old technique, old-fashioned technique. Think of numbers that multiply to that 4. That would add up to the -4. What are the two numbers? Dane? Yep. 3 minus 2. So guess what? The solution to this binomial is 2. The solution to this binomial is 2. And what that means visually is that parabola is just touching one place. If I would graph this to check my answer, that parabola would touch at 2. And that's the only place it would touch. It probably look like that. And if I would go to the calculator to graph this to check, what you see in the green box is what you would type in for that y equals. You wouldn't type in the equals 0 or anything like that. Okay. All right, a little geometry here for all you geometry scholars that are already missing that class. How many of you already missed geometry class? Huh. Fascinating. Okay. So the area of this rectangle is 24 square units. Maybe it's inches squared, maybe it's feet squared, I don't know. We have to solve for x. So this is going to be a little interesting. Somebody told me they actually did a problem like this last year. Basically, you have to think, how do I find an area? Well, I find an area doing length times width, right? So we're going to group this length, we're going to group this width, and we're going to multiply them together. So length times width is equal to 24. They did tell us that our area is 24. So we actually have to use a little bit of foiling. Hopefully, if you're not good with foiling by now, you get good at foiling quickly because it's a skill we're going to use all year. But x times x is x squared. X times -6 is -6x. -8 times x is -8x. And a -8 and a -6 is a positive 48. Alright, got a couple jobs here for you to do. You have to add these like terms together, but you also have to get the 24 over to the left-hand side. Because if we're going to be using our factoring and our solving techniques, we have to be set equal to 0. I'm going to subtract that 24 over to join 48. That will be a 24. And now we can factor it in order to solve for x. Box method or old method? The old method, old-fashioned technique. So we just need to brainstorm numbers that will multiply to 24 and add up to -14. I'll give you a second to think about that. What are those numbers going to make? I feel like Kyle knows. Perfect. -12 and -2. And that makes the solutions of this problem 12 and 2. But wait, this is a real-life problem involving real-life dimensions, like the dimensions of a rectangle. So you have to kind of check that your answers make sense. If I put a 12 in here, I would find out that the length of my box is 4. If I put a 12 in here, I would find out that the width of my box is 6. Everything's kind of okay with that. But what if I would put a 2 in for x here? I just realized my rectangle is not drawn to scale. I'm sorry. If you put a 2 in right here, would that make sense? 2 minus 8? You can never have a box with a negative dimension, so you just kind of trash can that answer. It's not that we messed up anything with our mathematics, it's just that that answer doesn't make sense in this real life scenario. Okay? Good. Alright, so we're going to be done, and your homework is on the rest of that paper. It's the bottom half. I actually already wrote it on there. 19 to 33 odds and 36. So thanks for watching the video. Happy weekend.